If we think of great animal migrations, that probably conjures up images of wildebeest in the Serengeti or humpback whales traveling all the way from Alaska to the tropics. But every single day, our lakes and oceans are home to the largest migrations of anywhere on the planet. It's called Diel vertical migration, and it describes the movement of trillions of organisms from the deep up to the shallows and back down again. Diel vertical migration was first noted way back in 1817 when French scientist Georges Cuvier noticed that Daphnia seemed to completely disappear from the surface of the lake he was studying during the day. Years later, US World War II naval warships inadvertently discovered the deep scattering layer of organisms when their sonar reflected weirdly through the midwater. The reflections were very thick and looked to them like sandbanks or even the bottom of the ocean, even though this couldn't possibly be the case. Since its discovery, scientists have been piecing together the data on why and how this happens. Nowadays, we know a lot more about Diel vertical migration, but not everything. A world expert on this is Kelly Benoit-Bird. So as a Diel vertical migration expert, of course I have to ask you, do we even know why this happens?
Probably the most important reason is that they're trying to balance getting enough food to eat while avoiding becoming dinner themselves. There aren't very many places to hide in the ocean, and so animals stay deep in the dark waters during the daytime to avoid predators that are looking for them. But of course they still need to eat, and food is most abundant in surface waters where light allows plants to grow. So animals move to the surface to forage under the cover of darkness at night before moving down deep in the water column to hide again during the daytime.
So from my understanding, we're not talking about just one species doing this, and we're not talking about this happening in one single area, is that right?
That's right. Vertical migration happens throughout the world's ocean and is carried out by tiny animals to large ones, from zooplankton to squid and fish. But probably the migrator we know the most about are these relatively small fish like this lanternfish, or the bristlemouth fish, which is the most abundant vertebrate on our planet.
Lanternfish get their name from the bioluminescent photophores on their body and heads. They use these lights in the depths to communicate with each other. As Kelly said, these are one of the most common fish in the entire deep sea. Scientists estimate that they make up around 65% of all deep sea fish biomass, weighing in at around 16 gigatons. That's 16 billion tons of glowing fish, weighing more than the entire human population combined. Even crazier is that bristlemouth populations are said to be in the order of quadrillions of individuals.
Each and every day, these animals go through these vertical migrations, making it the largest net animal movement on our planet.
And I'm assuming that it has some pretty serious implications for us and how we understand the ocean, right?
That's true. So the ocean has buffered us from the worst effects of climate change, taking up more than 90% of the heat and about 25% of the carbon dioxide that we generate from burning fossil fuels each year. So plants at the ocean's surface take carbon dioxide out of the atmosphere and use it for photosynthesis. If that carbon can get brought to the deep sea, it gets trapped and can't be re-released to the atmosphere. We're really just starting to understand how vertical migration plays a role in that. It may account for as much as 50% of the transport of carbon from the surface to the deep sea. I like to think of it kind of like a biological conveyor belt. These animals are eating at the surface, migrating down hundreds of meters where they're releasing their waste product, and rapidly moving that carbon out of the atmosphere. It's really important for the health of all of us on the planet.
This is also known as the biological pump. Scientists estimate that if this carbon sequestration didn't happen, the carbon in our atmosphere would be as much as 200 parts per million higher, rendering the Earth completely uninhabitable. Diel vertical migration is fundamental to Earth's natural rhythm, and we need to know as much about it as possible. That's why scientists like Kelly are using all sorts of techniques to better understand how these animals are moving and why. So Kelly, as I understand it, we usually take data and then analyze it later, but you are pioneering a way to take live data of these Diel vertical migrations. Can you tell me a bit about that?
We're really fortunate here at MBARI to sit at the head of Monterey Canyon, which is an incredible feature. It's deeper than the Grand Canyon and brings these animals quite close to shore where we can really study them. We've been working with a cabled observatory called Mars. This cable is about 35 kilometers from shore and gives us network and power access so that we can use our sensors continuously. One of the ways we study vertical migration is by using sonar or sound, where we send out a short pulse of sound and then we interpret how that sound echoes off animals within the water column. Now, using the Mars Observatory, we're able to take that information continuously so that we can start to understand how vertical migration changes from hour to hour, from day to day, and even over the course of years.
So, from what I'm hearing, this isn't just an up and down, every day, every night type of movement. You've figured out that this is more dynamic and it's changing, right?
Well, we're learning that animals are really finely tuned to the presence and behavior of their predators, which really isn't surprising because survival is so important. But we're learning at what timescales they do that. Vertical migration doesn't happen the same way every night. Sometimes we'll see no migration, and then suddenly a predator will appear, and in the middle of the day, all of the animals will migrate away from the surface and start their vertical migration pattern. Other times we'll see vertical movements at much shorter timescales than that. Juvenile hake, for example, respond to the presence of Risso's dolphins within seconds of us being able to detect them, diving tens or even hundreds of meters deeper, bringing them out of the depth range that these predators can dive to and really protecting themselves. So there's this delicate dance between predators and prey in the pelagic.
It is an amazing phenomenon, but to truly understand what's going on, you have to get in amongst this migration. And not far from here is a robot I know Kelly has used, and it does just that. I'm off to see Mesobot.
So Mesobot obviously doesn't look much like a fish, but it is designed to behave like one, right?
Well, more precisely, it can behave like all of the animals that migrate, that go from the deep ocean during the day so they can stay out of the bright light, but come to the surface to feed at night. So that's fish, it's invertebrates, it's all kinds of different animals. So yes, it can behave exactly like that because it can actually measure those very dim levels of light, and then it can act on those to keep the light level the same. So as the sun is setting, it will rise up just like the fish and the squid and all the other animals do.
Right.
And then at daybreak, it will descend down into the ocean. And so typically it'll go between maybe 50 meters and 500 meters. It's literally holding that light level constant, which is a crude model of what we think the animals do. Here we see Mesobot's cameras, 2 stereo cameras. And then this is what we call our science camera. Conventional propeller, but these turn very slowly. Radiometer. It can measure the ambient light levels, and it can measure them even when they're extremely dim. This is an acoustic beacon. This is a strobe light, a GPS receiver, and a satellite phone.
So how exactly does your work fit into the whole idea of climate change and the carbon cycle?
Climate models for many years have really neglected the role of the ocean or had very simplified models for that super important contribution. So the more we can understand those processes better, the more we can quantify them, the more we can improve our models and understand how the whole big system actually works.
So Mesobot is helping us to get all of those measurements, learn more about these animals, and understand those processes better.
Right. The more we can understand the daily lives of these animals in detail, how they respond to the light levels, how they move, how long they stay where they are staying, the better we can understand the role of the ocean in climate change.
So there you have it. We have the largest animal migration on the planet and a huge driver of Earth's carbon cycle happening every single day in our lakes and oceans.